Okay, this is the notes part 1 to topic 3.2, and I'll do a separate video for the notes part 2 for topic 3.2. So we're going to start with some definitions of angles in standard position. An angle in standard position is an angle with its vertex at the origin. You can see that the vertex is at the origin, and one ray of the angle lies on the positive x-axis, and the terminal ray is the second ray of the angle. So you would measure it from the x-axis to the terminal ray. This is what we call counterclockwise, and this is usually what we call positive. If we go the other direction to get to the same ray, we're in the same position, but now that angle is clockwise, and we consider those angles negative. Okay, so the sine of an angle is the ratio of the vertical displacement P, that's vertically going in this direction, so the vertical distance between the origin and point P. Okay, that's the vertical distance. And we measure that as sine theta, we call our angles Greek letters, is the y value of that point P over the radius. And the cosine theta is the ratio of the horizontal displacement, the x value over the radius. And the tangent is the ratio of the vertical displacement to the horizontal displacement, which would be the y over the x, or the sine theta over the cosine theta. And this is important. It's also the slope of that line from the vertex to P. Okay, so your first example says the figure shows a circle centered at the origin with an angle measure theta in standard position. The terminal ray of the angle intersects the circle at point P, where you have a value of x comma y. And we know our radius is 3 because you can see this point right here goes from 0 to 3. So that makes this radius 3. So going back to the definition of cosine, we need the x value over the radius. Well, we don't know the x value, but we know the radius is 3. So the answer to this is A. The cosine theta is the x value of point P over the radius 3, because it is the ratio of the horizontal displacement, x, over the radius, the distance from the origin to P. So cosine theta. Okay. And this one says the figure shows a circle with radius 5, because you can see this point has 5, centered at the origin with an angle measure of theta in standard position. The terminal ray intersects the circle at point P. Find the following values. So remember, the sine of theta is x over the radius. Well, we know that P has a value of a displacement of 3 on the x. But because this is 4 up and we're going 4 down, we have to say that's a negative 4. So we've got 3, negative 4. So if it's x over r, I'm sorry, the sine is y over r, I beg your pardon, then what our y value is negative 4, and our radius is 5. So the cosine, I'm sorry, is x over r, and that x value is 3, and the r is 5. And the tangent is the y over the x value, and the y again is negative 4, and the x is 3. All right, this figure shows a circle with radius r centered at the origin with an angle measure of theta in standard position. There's your theta right there. So the point P is xy. Q is going to be, because we're going in the opposite direction, the x values will be negative, but the y values will have to be the same. R, we're going completely through the origin to quadrant 3, where both x and y are negative. And S is going to be a positive x and a negative y. Okay, so find the coordinates of points Q, R, S in terms of x and y. So Q is going to be negative x. I'm going to have to write it down here because I can't write that tiny. Positive y. R is going to be negative x, negative y. And S is going to be positive x, negative y. So find the sine of the angle whose terminal ray intersects the circle at point S. Where is that? And so remember, the sine of theta is the y value over the radius. And if we're at point S, the y value is negative y and the radius is r. Okay, example 5, we have the same figure. Now they want the cosine of theta. So we're going to say the cosine of this angle theta at Q. Actually, they're saying cosine at Q, so it's not theta. We'll call it something else. We'll call it the cosine of alpha. Is supposed to be the x over the r value, but you can see at this point the x is going to be a negative x. So we're going to say it's negative x over the radius. And then find the tangent of r, which we'll call the tangent of angle beta. And that is supposed to be your y over your x value, but we know both y and x are negative. And of course, the negatives cancel each other, so we're just going to get a positive y over x. Example 7 says, let theta be an angle in standard position whose terminal ray coincides with the line negative 3x in quadrant 2. So if I did that, it would be a steep line with a slope of negative 3. And so when we say, what is the sine of theta? We know that that is going to be, well, let's do this first. We also know that the radius is the square root of the x squareds plus the y squareds. And what we can say is, we know that y is negative 3x, so we're going to say that's the square root of x squared plus negative 3x squared. I'm just substituting y in for here. So negative 3 times negative 3 is 9, and 9 plus 1 is 10. So that's the square root of 10x squared, or the square root of 10x. I'm taking the squared x out. So the sine theta generically is the y over the r. Now we know that y is negative 3x is defined up above, and we know r is the square root of 10x. Well, the x's will cancel, so we are left with negative 3 over the square root of 10, and we could rationalize that and say times square root of 10 over square root of 10, and that will give us negative 3 square roots of 10 over 10. The cosine theta is going to be x over r. And we know that the x is going to be, so here we're going to set this r equals, let me show you this, r equals the square root of 10x. We're going to divide both sides by the square root of 10. So I know now that x is r over the square root of 10. And I also know that it's negative in this quadrant. So it's going to be negative r over the square root of 10 divided by r. Well, the r's will cancel, and you're going to get negative 1 over the square root of 10. And if I rationalize that, that would be negative square roots of 10 over 10. And now the tangent theta, if you recall, is the slope, or the y over the x value. So we know that y is negative 3x. And we know x is x, and the x's cancel. So the tangent is simply the slope of that line, or negative 3.